Okay, now I am just trying to give you a problem. You tell me like how this thing is being done. See, look at here. Here, what happened? If you look at this particular table, this is partition table, right? So we have got the internal fragmentation here. The fragmentation is internal. The space is internally marked, right? We have got a internally free space, internal free space here. Now, if you look at static, this is internal space, internal fragmentation. But if you look at dynamic, that is at the end of the memory, we have got a free space here. At the end of the memory, we have got a free space, and we have got a variable sized partition here. So which means that one state is something like this. In a broader perspective, one state is something like this, where we have got some partitions onto user space, where we have got a free space, something like this, variable size free space we are getting, right? Say for example, this is free space, this is free space, right? This is free space, right? This is going to be a free space, a free space likewise. So if we look at this particular partition, if you look at this particular partition, you'll find that uh, each, say how many partitions are here. If you look at this, is say this is partition number 1, this is partition number 2, this is 3, this is 4, and this is 5. So there are 5 partitions. Say just take a case that each of this partition is of 200k, right? We have got 5 partitions, okay? And for example, 5 partition, each partition is of 200k. Okay, so that means the user space that is available to me is say 1000. Simple. Okay, because it is 5 partitions, right? 5 partitions are there. So this is 1, this is 1, this is going to be 2, this is going to be 3, this is going to be 4, and this is going to be 5. Okay, so in this case, say for example, this is T1 of 100, right? T2 of 150, right? T3 of 100, T4 of say 10, and T5 of say 190. Okay, so means what? This free space is of 10k, this is of 190k, this is of 100k, this is of 50k, and this is of 100k. So if we sum all these together, we'll find that 100, 100, 200, 200, 200, 400, and 450. So if we sum this with say free space, we have got 450k free. Right here. Now, if this specification we talk as, if we consider it as a static specification, okay. So where in case of this static specification, right, the partitions are of fixed size. Now, to this we are going to extend one more case, right? Say for example here. Now, what is going to happen? Say first partition 100k, second partition 150k, third partition we have got 100k, fourth partition say we have got 10k, fifth partition we have got 190k, so this is 190k. So what is going to happen at the end? We have got 450k free. Okay, so this is zeroth party, this is one partition, this is second partition, this is third partition, this is fourth partition, this is fifth partition. So this is with the what? Dynamic specification. Okay, so this is with the dynamic specification. Say if you look at if you look at the deallocation mechanism, right? If you look at the deallocation mechanism, if this if just assume that this 100 and 150 gets deallocated, So what is going to happen here in case of a static specification? If these two are deallocated, this T1 get deallocated, T2 get deallocated. So what is going to happen? The state is going to be like this. So this is going to be 200k free, and this is going to be again 200k free. Okay, now this is T3. The T3 is going to be here, say T3, then that is 100k allocated, 100k free. So here it is 100k free. Okay, T4, right here it is T4 is say 10k. So this means that 190k free. This is 190k. So this is 190. This is 100k. Okay, and let us take one more example. Right here T5 you have, and T5 is say 190k allocated and only 10k free. Okay, so means what here? Here the case is that 200, 200, 400 plus 100, 500 plus 190 is say 690, and this is 10 is 700. So if we move, take out this T1 and T2, we are going to have a 700k free. But the partition which we have created is of 200k size, a constant size partition. We are going to get it here as it is, right? So though there exists an internal fragmentation here, internal fragmentation, but the case is that when the task is being deallocated from the system, the partition is going to recover to the original size. Okay, so 100. But in this case, just assume that if suppose this T4 and T3 gets deallocated. If suppose T4 and T3 gets deallocated, right? If suppose T4 and T3 gets deallocated and the state is going to be something like this, so we know that this is say 100k free and this is 10k free. So this is 10k partition, this is 100k partition. So previously we are getting again re-getting the 200k partitions. Here we are not getting 200k. One is 100k, one is 10k. Then we have got a 190k allocated. This is say 150k allocated. This is 100k allocated. Okay, so this is the status is this is free, the status is this is free, and this is free. So here it's again 450k. So this is 450k. Okay, so this is allocated, this is allocated, this is allocated. Now what I wanted to understand that if suppose now I have a task, say task T6 T6 of 101k or say 110k, right? So where this is going to get fixed, where this is going to get fixed, is it going to like is it going to be in this 450k, or is it going to be into this 100 and plus 10 is 110k, where it is going to get fixed now at this particular point of time? Can you suggest me
So
the best
100,
possible space for this?
so 140K.
uh, 140k, where it is
100.
140k? See, this is allocated, so you cannot fix this in this allocated space. You have a chance of like either possible condition is you can think of this particular space, or you can think of this particular space. Right. So where you are going to do, or I can have one more thing is that, say for example, I have T7. T7 is of say 90k, right? T7 is of 90k and T6 of 110k. Like where we are going to place this particular uh, task T6, T6 and T7.
So may I answer?
Yeah.
The sir, the T6 will allocate in
Yes.
the 450K. The T7K will allocate in the 100K.
Okay, so for like what, as per your suggestion, you're saying that for this, for T6, the best space will be in the free portion, right? In the free portion of memory, right? Right, and this free portion is right now it is of 450K, and for T7 the best position is, right, best space, we can say this best space is going to be 100K partition. Okay, 100K partition. Okay,
Sir,
so the best space is this. Okay, so
um,
if yes, any other?
sir, can I answer again?
Yeah.
Sir, the best space for the T6 will be 100K and 10K, because it will use all the memory.
Mhm.
Uh, and for the T7, I think so. It will not the best, but सर इसमें नहीं क्या फिर वेस्ट होगा.
Okay, okay. Okay, but now see, you are saying that this is one option, huh? This is option one, hash one. This is hash one option. This is also hash one option. Okay. Now we are going to have hash two option as suggested. That for this T6 hash two option could be merging of 100K plus 10K partition together, and making that particular partition of 110K size, right, and allocating it for allocating it for T6. Okay. Now for this T7 again, then if we merge these two partitions together, then for T7 again you are going to have a free space as the option. So like if this is going to be, then for hash two option for T7 is free space. Okay. Any more solution that you have? Then we'll discuss on to this.
No, sir.
No. Okay. So the case right now the case is the point is you cannot think of this way, right? You cannot think of this. You cannot go ahead with this, right? Because right now we don't have any mechanism of merging the partition all together, right? Here we don't have any idea, any mechanism of merging the partition, right? So this is not going to be done. So this is again not possible for us to think of, right? Because the best method that is available is to go with this. Okay, so I do agree that if we go ahead with this, there is it is said that there is a waste of memory, but it's not going to be a waste of memory. Almost what is going to happen that we are going to create one more partition here. This particular partition will be of 110K. So by this, what is going to happen? Instead of this 450K, we are going to have 340K free, right? And which is going to be like this. At the end, we are going to have 340K partition free. So we have 110K partition, right? Now, but the case is that if this gets like, see, let us try to go for it. So this can be furtherly being done in this particular way. So we have, say, we have got, these are 100K allocated. This is 150K allocated. Then we have got this of 100K free, this is 10K free. Okay, then we have got 190K, right? Then we are going to get 110K. We are going to get 110K allocated and 350K, 340K free. Okay, so this is going to be, so this is again the free space that we are going to have. Okay, so this is allocated, this is allocated, this is free, this is free, and this is free. So this is going to be allocated, allocated. So means what? These two tasks are being allocated here, two tasks are being allocated. So initially, before going to this, we have got only three task allocated. Now we have got four tasks allocated here. And the problem is like, see, if this gets deallocated, say 100K gets deallocated. Now we have got, means the time you allocate this 110K, this particular task T6 here, at the same time, we have got now state that, okay, the time this gets allocated, we have got this as free also, this 100K as free. So this 100K is free, right? So then we have got 150K allocated. Then again, we are going to have this 100K free, right? Then we have got this 10K free, right? Then we have got this 190K allocated. Then we have got this 110K allocated and 340K free. Now at an instance of time, say this is with the T0 time, and the time T0 is being at the time of T0, 110K is allocated. At the same time of T0, what has happened? This got a free. Okay, so now you have got a partition. Now you got a two partitions here. Okay, and a task of T7. Now where you are going to place now T7? You tell me. In this case, where you are going to place T7. Now T7 is of 90K. Are you going to place it here onto a zeroth partition, or are you going to place it onto a partition number 2, or this is
Your
3,
voice is
4,
breaking.
5, or 6? Where you are going to place? Huh? Yes, where you are going to place?
Sir, zero partition.
At zeroth partitions. Okay, so at zeroth partition you are going to place. So here the interesting thing is that, see, since this kind of variable partitions are getting created, so you need when you need to put more effort. So this is important. Important point is the system has to take effort in deciding the best possible or best suitable partition, decide best suitable partition for the task, right? So you have to decide, the system has to take an effort in deciding the best suitable partition for the task, right? So this is the major challenge that we are going to have. How we can decide the best possible partition for a task which is in the queue, and for which we need to allocate a memory. So for this